here we're going to look at translating graphs of functions. And so the big thing you want in your notes probably is this top part about vertical and horizontal. What does it look like in the equation? And then what does it look on the graph to translate something? So they're saying a fast way to graph is if I already know, say, something like y equals x to the third, if I can recognize that this is a version of y equals x to the third, because it's something to the third, you can add or subtract something at the end of the function or from x, and all that does is move it up and down or back and forth. So for vertical, if you add something outside the function, it moves it up. If you subtract something, it moves it down. So that's kind of the way you would want it to be. The way I remember the right and left ones is basically that they're the opposite of what you would expect. If you do something minus off of x, it actually moves it to the right. And if you do something plus, it moves it to the left. It's basically because you're kind of compensating. Like, say right here it says plus 1. To get 0 out of this, I have to put in something that's 1 smaller to make up for the plus 1. And so that's the reason those work backwards. So if I look at a function like this, x plus 1 to the third minus 3, all I'm trying to see is what was done outside of the function and what was maybe done to x. And so outside of the function, they did a minus 3. So I know that that moves it down 3 units. And then inside the function, they did a plus 1, plus something moves it to the left. And so now if I want to make the graph of this, it looks exactly the same as this graph. I just want to go left 1 and down 3. And so if this one crosses 0, 0, and you could take any point, but this one happens to cross 0, 0. So I go left 1 and down 3. So it'll look like the exact same picture. It's just moved left 1 and down 3. So looking at the equation and seeing how it's different from this base equation.